Today's lesson we are going to be building upon what we have reviewed from Algebra 1 in Sec 3.1 and 3.2, so solving system of equations, but now we're going to be looking at real-world situation. A problem where you've got the situation described, you actually have to come up with and write your system of equations. Now, there are a couple things that I want to make sure that everybody does, because if you don't do all of these things, it's going to be very confusing for you, and it's also going to make it very difficult for me to figure out where you are if you have a problem that you run into, and if you have something that's incorrect on a quiz or a test, it makes it hard for me to give you partial credit if you don't follow these steps. And they're not too tough. The first one is the one that most people forget, and that is to define your variables. So tell me what the variables that you're using stand for, because they all stand for something in word problems. Second step is you need to clearly write your system of equations. So every problem that you are going to be solving in these notes and then in the practice problems for your classwork, there should be two equations that you are writing, both having the same two variables. So if you're using x's and y's, if you're using a's and b's, they should both have both variables in most cases. Then 3 and 4, 3 is to solve the system. So that's using the math that we've already reviewed. You can choose your method. I usually don't choose graphing for any of these just because it's not easy to draw out your graph, whereas if you're using an algebraic method, that makes it a little bit easier to show your work because you do need to show your work. Step 4, and of course I've run out of room, so we'll put it up here. Step 4, something that people always forget, 1 and 4, people always forget these. Step 4 is to make sure you actually answered the question. And don't forget appropriate labels. So if it's asking how many of something, you tell how many of each thing they have with labels. Okay, so let's look at example 1. Example 1's not really a real world situation as much as it is just getting used to the words. So you've got words here. We basically are translating, as if it's a foreign language, from the words into the math. So read it through once. The difference between twice one number and a lesser number is 32. The sum of the lesser number and twice the greater is 60. Find the numbers. When I read it through the first time, the only thing that I take out of it the first time I read it is what I'm looking for, because that's how we get started, how we define our variables. So step 1 here, I'm going to say if I want to find the numbers, I need to define one of my variables as the lesser number and one as the greater number. So it doesn't matter which one you make which, but I'm going to make x my lesser number, and I'm going to define y as my greater number. Now, once I've done that with my first read, now I go back and I read it again to start step 2 to come up with my actual system. So the first sentence, and I do this one sentence at a time usually, the difference between twice one number and a lesser number is 32. That sentence should translate into an equation. When you see the difference between, difference in math means subtraction, so we're going to be subtracting two things. What are we subtracting? Twice one number and a lesser number. So twice means to multiply by 2, and when we're subtracting, we subtract the smaller from the bigger. So twice one number, it's going to be twice my greater number, and a lesser number. The lesser number we said was x. Is in math means equals, so 32. So reading through the second time, I came up with one of my two equations. My next sentence, I'm going to read it a little bit closer. The sum of the lesser number and twice the greater is 60. So again, one little piece at a time. The sum. Sum means to add. So we're going to be adding two things together. The sum of what? Of the lesser number, so that's x, and twice the greater. We already said twice means to multiply by 2, so twice the greater is 2y. Is means equals 60. So now I've got step 2. I've got my system of equations. Now I'm going to solve it. I'm going to switch to a different color here so that we can not have it all run together. Now, you get to choose which method you want to use to solve it. So yours may not always be the same as mine, but you should get the same answer. So step 3 is to solve this. Now, I have two choices. I can either do substitution or I can do elimination. On this one, I'm going to go ahead and use substitution because my bottom equation here, that's really easy to get the x alone by just subtracting the 2y. So that's what I'm going to do first, is get the x alone in that bottom equation so that I can substitute. So I go back into the top equation. I take my x out. So leave my little hole. Again, just like before, remember I've copied everything else from that first equation exactly how it was. I just left a hole where the x was. Now I put in what x was equal to, which is negative 2y plus 60. And now I should be able to solve. So distribute my negative. So 2y minus negatives become plus. So that's plus 2y plus 60 equals 32. Pen's catching a little there. 2y plus 2y, I know those like terms, and I'm going to subtract the 60 to the other side. So 32 take away 60. Ooh, and I fake that I made. Not often do I find mistakes when I'm working through this, but here it is. When I distributed my negative, I forgot to make subtraction. So that should be a minus 60. So actually, I should be adding 60 to both sides. Good thing I caught that now. 32 plus 60, then, I'll go back to the color I was using, gives me 92. So if 4y equals 92, divide by 4, and y is 23. Now, I'm not finished. Solving a system means find both. If y is 23, I now need to find x. So plug that back in up here. So x equals negative 2 times 23 plus 60. So negative 46 plus 60 should give me 14. So I've solved the system. You do not, on word problems, need to write your answer as an ordered pair because ordered pairs don't really make sense for word problems. We need to answer the question in word problems. So that's step 4. Answer my question. It says find the numbers. So 14 is the lesser number. 23 is the greater number. Remember that you can check these to make sure that they make sense. So plug them back in to the word problem and make sure that it works. All right, let's look at a different type of problem now, and one that is real world situation, not just words. Hannah has 126 coins. Some are quarters and some are dimes. The total value of the coins is $16.50. How many of each coin does Hannah have? Again, the first read through, the only thing I focus on is what am I looking for? Because that defines my variables. So, step 1, how many of each coin? So, the types of coins I have are quarters and dimes. So, I'm going to let x equal the number of quarters. And I'm going to let y equal the number of dimes. Now, some people prefer to use alternate variables other than x and y. I do that as long as they're not going to look like numbers. So if you do that, that's perfectly fine. You don't always have to use x and y. All right, step 2. Now we're going to go back and read it a little bit more closely and turn the words into equations. Hannah has 126 coins. Well, that should turn into an equation. Because x is my number of quarters, y is my number of dimes, I know total that has to equal 126. So x plus y equals 126. Some are quarters and some are dimes. We already used that in step 1. Sentence 3, the total value of the coins is $16.50. So most people from that know that that means over here I need to have $16.50. However, some people get confused about what goes over on the left. You can't just put x plus y again because it's not number of quarters plus number of dimes that equals $16.50. It's the value of the quarters plus the value of the dimes that equals $16.50. So we're writing one equation to represent the number. We're writing a second equation to represent the value. So because you know the value of quarters and the value of dimes, you should be able to get this. Value of quarters is going to be 25 cents times however many you have, which is x. Then I need to add to that the value of the dimes. I know that dimes are worth 10 cents, so 0.1 times however many of them I have, which is y. So value of the quarters plus value of the dimes equals total value. So there is my system. Now I want to solve it. So again, you can use whichever method you want to solve these. If you prefer the elimination method, you can use that. If you prefer substitution, you can use that. Since I did substitution on the last one, I'm going to do linear combinations here. So I'm going to try to cancel my y's out by multiplying my top equation by negative 0.1. So if I do that, that gives me negative 0.1x minus 0.1y equals negative 12.6. So now I've got my opposites on my y, so that means I can go ahead and add straight down in my columns. I've got 0.25x plus negative 0.1x, so that gives me 0.15x. My y's cancel each other out. Then on my plain numbers, I've got 1650, and I'm adding negative 1260, which gives me $3.90, so $3.90. So now divide by the 0.15, and x equals 26. So that tells me I've got 26 quarters. Now I need to find the number of dimes. That one should be easy. Plug it back in. So 26 plus y has to equal 126. Most of you can do that in your head. So y is 100. My pen wasn't working there. So last step, of course, is to answer the question with labels. So it asks, how many of each coin does Hannah have? So you say 26 quarters and 100 dimes. Example 3, a mixture problem. All right, dried apricots worth $5.75 a pound were mixed with dried bananas worth $3.80 a pound to produce a mixture of dried fruit worth $4.25 a pound. How much of each kind of fruit were used to produce 52 pounds of dried fruit? All right, so again, first reading through, I identify what I'm trying to find. How much of each kind of fruit? So for step 1, I'm going to let x equal how much. So we're measuring that in pounds. So x is going to stand for number of pounds of apricots or apricots, however you say it. Then Y is going to stand for the number of pounds of the bananas. If I can spell banana. There we go. Looked like too many A's and N's. All right, now I'm going to read through again. The dried apricots are worth $5.75 a pound. They're mixed with dried bananas, worth $3.80 a pound, to produce a mixture of dried fruit worth $4.25 a pound. The other key information, we're producing 52 pounds of dried fruit. So this is kind of similar to example 2 in that my first equation is just the number of pounds. So apricots plus bananas has to equal 52 pounds. The second equation has to do with value. So the number of pounds of apricots, I'm going to take that and multiply it times however much they cost. So 5.75x, and then it's plus 3.80, you don't have to write the 0, y equals, now here's the tricky part, a mixture worth $4.25 a pound per pound. You can't just set it equal to $4.25. It's $4.25 times however many total pounds there are. And they told us how many total pounds there are. There are 52. So that's the tricky part on this one, is that it's not just equal to $4.25, it's $4.25 times 52. So I'm going to use substitution on this one, or kind of go back and forth here. So to solve this, I'm going to get my x by itself in that first equation by subtracting the y. So I've got x equals negative y plus 52. So then I'm going to substitute that into the second equation in place of my x. So 5.75, leave a hole for my x. Then it says plus 3.8y equals, I'm going to go ahead and simplify this right side because I can take 425 times 52, which gives me 221. Now I'm going to plug in my substitution, so negative y plus 52 in here, and now I'm going to solve. So distribute, so negative 5.75 y plus 52 times 5.75 is 299 plus 3.8y equals 221. So combine like terms. I've got like terms right there. So negative 5.75 plus 3.8 gives me negative 1.95 y. And then plus my 299 equals 221. So next I'm going to subtract the 299 on both sides. So I've got negative 1.95 y equals 221, take away 299 is negative 78. So now divide. You should get y equals 40. Whew, that's the hard part. Done. If y is 40, plug that back in here. X plus 40 has to equal 52, which again, many of you can do in your head. That means x is 12. So my very last step is to make sure that I have answered the actual question asked, which is to say I need 12 pounds of the apricots and 40 pounds of the bananas. All right, last example, and this one is a little bit tricky, so don't feel bad if it's a little hard to follow. One car travels 30 kilometers faster than another. In the same time that one goes 250 kilometers, the other goes 400 kilometers. Find their speeds. Now, I want to preface this by saying there are lots of different ways to solve this problem. So if you solve it different than me, that doesn't mean yours is wrong. This is just the way I'm walking through it. So first thing, identify what I'm looking for. I'm trying to find their speeds. So I'm going to make x equal the speed of the slower car, and I'm going to let y equal the speed of the faster car. Step 2, write some equations. One car travels 30 kilometers per hour faster than another. So the faster equals the slower plus 30 kilometers per hour. Now, you could write this a variety of ways. You could write y minus x equals 30. You could write x minus y equals negative 30. Bunches of different ways to write that first equation. The tricky part is the second equation, because it brings in a third equation that you should know but probably might not think to use. And that is, look at the title, Distance, Rate, Time Problem. You learned a long time ago that rate times time equals distance. And the key word, if we read this really closely, it says in the same time. That means the amount of time that the two cars are traveling is the same. So if I put this formula in terms of time, time equals distance divided by rate, the two cars have the same time, which means if I have distance over rate for one of them that equals time, that should also equal distance over rate for the other, which is how I came up with my second equation. The distance that the first one goes, and that's going to be the slower one, because slower ones are going to travel less in the same amount of time. So distance was 250 kilometers. The speed of the slower car is one of my variables. That's my y, or that's my x, the slower. I know that has to equal the distance over rate of the other. Distance of the faster car was 400. Speed of the faster car is y. So, a little bit tricky to set this up, and I wouldn't expect you to set one like this up that you hadn't seen before. Once you've seen this, you should be able to duplicate it, but I wouldn't give you one this hard without instruction on a quiz or test. So, here, this is a proportion, and I can solve proportions by cross-multiplying, but I need it to only have one variable, which leads me to my step 3. I'm going to solve this by substitution. I'm going to take y out here and put this in instead. So 250 over x equals 400 over, instead of y, I'm going to put x plus 30. So cross multiply, x times 400 is 400x. On the other side, I need to remember to distribute 250 times the x and 250 times that 30. It's important that you remember to do both, so that gives you 7,500. So subtract the 250x on both sides, gives you 150x equals 7,500. Divide by 150, and you should get x equals 50. Once you have that, plug it in. Y equals 50 plus 30, which is 80. So find their speeds. Slower car goes 50 kilometers per hour, and the faster car goes 80 kilometers per hour. And that is it.